All right, I'm back. We're on page 271. It is dark as anything outside today, so I actually dragged a lamp over to kind of illuminate this situation. So it's probably the brightest that it's ever been. We're still evaluating limits, and let's just dive in and see what we can do. So this first one here, we got the limit as h approach. So the variable doesn't matter, but when you're doing these problems, when you look at a limit, that is telling you what the variable is. So if there were x's and h's in this, the actual variable in this case would be h, and then x would be considered a constant. It's not going to come up for a couple of problems, but that's an interesting thing to notice. So the limit is telling you what can vary in the problem. We look at this. First step is always try to sub right in. So this will give me 5 minus 5 is 0. And the denominator gets square root of 9, which is 3, and then 3 minus 3 is 0. So we get 0 over 0. So we're allowed to do some algebraic things, whatever we know. Like if there was trig, we could do trig things. So what I'm going to do here, it's kind of the opposite of what you practiced. But if you see something that you think you could rationalize, try rationalizing. So I'm going to try rationalizing the denominator on this and see if it helps. So what I'll do is the limit as h goes to 5 of h minus 5 over radical h plus 4 minus 3, and then we're going to multiply by radical h plus 4 plus 3. So you don't change any, the only plus or minus that you change is between the radical thing and the other thing. You don't change anything inside of a radical. So it's still h plus 4 and then plus 3 over h plus 4 plus 3. All right, the whole idea here, I'm going to put this in parentheses because I feel like if it's unclear, I always put it in the parentheses just to like clear it up a little bit. Let me see how I'm spacing this. All right, I'm going to go horizontal on this. You don't want to ever expand the part that you're not rationalizing, right? We're not rationalizing the numerator, so let's not expand that. Let's just, we got to write our limit. I don't know if you can hear the rain. It's crazy out there today. H minus 5. I didn't know this was going to happen in the rain situation, but like I never really check the weather anymore because I don't really go anywhere. So it doesn't impact me, which is kind of nice. I mean, that's, you know, a small minor perk here. All right, so then when you rationalize, you get a plus b times a minus b, which is a squared minus b squared. So in this case, a is radical h plus 4. So if I square that, I will get h plus 4. I'm going to put that in parentheses for really no reason. And then minus 9. Okay, if you did this right, then when you rationalize, like these problems are kind of contrived, like they almost always just work out. It should be the case that the thing that was giving you 0 in the numerator, that h minus 5, should cancel now. And if we simplify this, if we simplify this, I still have to write the limit because I'm still writing h's. I'll get h minus 5 radical h plus 4 plus 3 over h minus 5. Perfect. All right, so I haven't been checking on each step because I know what's going to happen, and you know what's going to happen. At each step so far, if we'd plugged in 5, we would have gotten 0 over 0. As long as you're getting 0 over 0, you just kind of like keep going. So here, when I cross this out, though, I'm going to simplify. So I'm going to write the limit, though, because there's still an h. As long as there's an h in this problem, I'm going to keep writing limit. When its limit as x approaches something, as long as there's an x, I'm going to keep writing the limit. You just keep writing it as long as you need to. But once you're not writing the variable, you can stop. Don't like over limit, which is something that people do. All right, radical h plus 4 plus 3. So square root of 9 is 3 plus 3. I get 6 as my final answer for this. I think it's right. I don't know. If you look at the work, we got all the limits that we need. It looks like good work. All right, let's look at the next one. That's gonna be the worst when I find out that I did like half the problems wrong. Just like algebraic, not algebraic, like arithmetic is the #1 thing that I'm a little worried about in these videos because I'm not really checking it. I'm just like going for it. But I don't think I've made too many mistakes, hopefully. All right, what is happening here? So we need to figure out just in general what's happening. So, all right. I'm going to look at the graph of 1 over x minus 1, which is 1 over x shifted to the right. So this will be a graph of 1 over x minus 1. So 1 over x, you should have it in your head. You should just know what that looks like. That'll pay dividends forever. I feel like I have a button that is occasionally like really reflective. And as soon as I set there it is. See that? Maybe? I don't know. I see it. All right. That's one of the graphs that you just want to know. Like you wake up in the morning, you review your graphs, 1 over x is in there, absolute value of x over x is one that you recently added. All right, so the first limit, if I approach 1 from the left, is going to be negative infinity. So right now this is negative infinity minus, now I got to think about this other one. All right, so 2 over, so I'm going to think of it as 2 over x squared minus 1, which is 2 over x plus 1, x minus 1. All right, let's see. 2 over x plus 1, x minus 1. I don't know that I really want to graph this whole thing. So it has vertical asymptotes at negative 1 and 1. Negative 1 and 1. I know that if I go to infinity, I'm going to get 0. Let's put in the asymptotes. If x is a billion, then I get positive. And so if it's negative a billion, I get a positive. If it's like 0, I get a negative. So I'm pretty sure that this looks like this. Review, if you're not sure about this, review graphing rational functions. So there's some videos on the like YouTube channel. It's in your notes somewhere. All right, so the limit as x approaches 1 from the left on this graph, 1 from the left is this. Okay, so also negative infinity. So negative infinity. All right, so what we're getting here is we're actually getting infinity minus infinity, which if you remember is one of those pseudo indeterminate forms, and you can deal with those because you can usually turn them into an indeterminate form. The way you deal with this particular one is you just get a common denominator. So that's what I'm going to do. So I'm going to rewrite this as the limit as x approaches 1 from the left of, all right, so I rewrote this one as x plus 1, x minus 1 in the denominator. So the common denominator between 1 over x minus 1 and 2 over x squared minus 1 is x plus 1, x minus 1. The left-hand fraction just needs an x plus 1. So I'm going to multiply the top and the bottom by x plus 1. So I'll end up with x plus 1. Do it in a different color. Over, it's x plus 1. And then x minus 1 was already there, I think. Yeah. X minus 1. And then minus 2 over, and this is already x plus 1, x minus 1, but I'm going to write it like that. All right, I'm going to put this in parentheses because I feel like it's not obvious that the limit is going to distribute, so make it obvious. And here, let's simplify this. The limit as x approaches 1 from the left of, so I have x plus 1 minus 2 is just x minus 1. So x minus 1, can you hear the thunder? I don't know what this mic does and doesn't pick up. It's thundering outside. It's raining incredibly hard. It's nuts. And then here, x plus 1, x minus 1. The x minus 1s can cancel, so we algebraically simplify before we try to evaluate. The limit as x approaches 1 from the left. Okay, x minus 1s cancel. We get 1 over x plus 1. Now I can plug in, and I'm going to get 1/2. What the heck? Crazy, right? So we get infinity minus infinity. So like in some sense, these two infinities differ by exactly 1/2, because if you subtract them, you get 1/2. That's a little thought that I like to have. I like to think about that from time to time. Like, what's going on there? Like, that's weird. But look at the techniques. Graphing helped us figure out the limits. Factoring, a lot of algebra stuff. There's just a lot going on. All right, let's take a look at this one. Oh, you know what? This video is probably kind of long. You know what I'm going to do? I'm going to cut it off, and I'll come back in another one and finish this page. So I will see you there.